Okay, so circle theorems. So this is a bit long-winded for something that's very, very simple, but it comes up in the exam. So first off, we have a circle here. Okay, now a line that's drawn across a circle, okay, we call this a chord. Okay, and this divides the circle up into two parts. Now, contrary to popular belief, okay, these two parts here are what we call segments. Okay, these are segments. So this would be the minor segment and this would be the major segment. Okay, equally this is an arc. Okay, the whole circle is an arc, but this would be the minor arc and this would be the major arc, purely because of their size, nothing more complicated than that. What most of us tend to believe is a segment is something like this, okay, where, you know, we would have, I don't know, the segment of an orange, for example, some sort of citrus fruit. Now we call this a segment, okay, but this is actually called a sector. Okay, so just to confuse you a little bit more, what you always believed was something isn't. So this is a sector and this is a segment. Now I wouldn't get too hung up about this because it tends not to come up, but it's something that is good to know. Okay, so the rules that you need to know. One is this: any line that's a tangent to the circle will always meet the radius at a right angle. Okay, this and all of these rules are cast in stone. So any line that is a tangent to the circle will always meet the radius at a right angle. Okay, this makes common sense when you think that there are an infinite number of radii. So if you're meeting, if a tangent is touching a circle, it will meet one of the radii at a right angle. Okay, so that's nice and simple. Second one, if we have this shape, this is the center of the circle, this angle here and this angle here are related. Okay, so the angle here is always twice the angle here. The angle here is always half the angle here. So for example, if this was 80 degrees, this would be 40 degrees. Okay, very, very, very simple. Moving on to the next one. Here we have this, for those who look at Star Wars, an X-Wing fighter. How sad am I that I know this. Okay, but if we have this shape, this doesn't have to go through the center line, but if we get this shape, this angle, if it's x, this angle also will be x. If this angle is y, this angle also will be y. Okay, you'll have similar triangles. Now sometimes with this one they'll say, okay, well if this angle is 50 degrees, what's that angle? So we know that's 50 degrees, and they'll say y. The stock answer is that they are subtended by the same arc. Okay, so subtended just means is hanging from. Okay, it's hanging from the same arc. So if I was to do this, okay, then we know this is a minor arc, and these two angles here would be hanging. If I turn the circle upside down, they would be hanging from the same arc. So we say that they're subtended by the same arc. Equally, if I was to do this, then these two would be subtended by the same arc because they're hanging from this arc. Okay, so y will equal y. Okay, so they're very, very simple. Okay, when I've shown you them, then I'll give you a couple of little problems just to show you the typical sort of exam questions. Okay, so I'll pause just to clear the screen and put some more up. Okay, so we have three more. Okay, so if we have a triangle and all three vertices, okay, vertices or vertex is the point of the shape. All three vertices are touching the circle, okay, and it's also touching a line that's at a tangent to the circle. Okay, now this angle here, okay, will always be equal to the angle furthest away. Okay, so if this was 60 degrees, this would be 60 degrees, okay, because this angle and this angle is furthest away from it, so these two angles will be the same. Equally, this angle here and this angle here will be equal because this angle down to the line is always equal to the angle furthest away. Okay, now this particular circles theorem has a name. They don't all have names, but this one is called the alternate segment theorem. Okay, and if you look in your textbooks, you'll see exactly what I'm talking about. So this angle here is equal to this angle here, furthest away. Okay, so if they said to you this angle here is 80 degrees, what's the angle here? We would say 80 degrees. Why? It's the alternate segment theorem. Okay, so now we have another circle, and this is the diameter of the circle. It passes through the centre of the circle. If any line comes from one side of the diameter, goes to the circumference and comes back to the other side of the diameter, it always creates a right angle. Okay, it doesn't matter where you go. So if I was to go from here to here and then from here to here, this is a right angle. Okay, so that's quite a nice easy one. They like to put this particular one in the exams. So if a line if a line comes from one side of the diameter, hits the circumference and goes back to the other side of the diameter, it will always create a right angle. Now here we have a four-sided shape. Now four-sided shape, you should know, is called a quadrilateral. Okay, quad as in four, lateral as in side, so four-sided figure. All the vertices, the pointy bits, are touching the circle. Okay, so this makes it a particular type of quadrilateral. Okay, it's what we call a cyclic quadrilateral. Okay, so if all four vertices are touching the circle, then it's a cyclic quadrilateral, and this rule only applies to cyclic quadrilaterals. If it is a cyclic quadrilateral, then opposing angles always add up to 180 degrees. Okay, you remember I said to you, any quadrilateral, it has four sides, you can't lose angles. So the inside angles, this plus this plus this plus this, will add up to 360 degrees. Now because it's a cyclic quadrilateral, x plus y will equal 180 degrees. Okay, so opposing angles always add up to 180 degrees. So it follows that A plus B must equal 180 degrees. So again, in the exam, if they said to you this angle is 110 degrees, what's this angle? Well, 180, take away the 110 will give me 70 degrees. So this will be 70 degrees. Why? Because opposite angles of a cyclic quadrilateral add up to 180 degrees. Okay, now I know that's quite a lot to remember. You've got 6 circle theorems to remember, but they're quite simple. I believe that they're quite simple. Okay, so what I'll do is I'll pause and I'll pose a question which involves all of this. Okay. Okay, so here we have a problem. So we have a circle and we have 2 lines that meet that are tangential to the circle. Okay, and they want us to find angle X. So this is the angle excuse me, this is the angle they want us to find. Okay, so as with most things with mathematics, I tend to break it down into 3 sequences. What do I know? What do I need to know? How can I get there? Okay, the only angle I've got is this angle, 40 degrees. Okay, and this circle is touching both lines. Now, one thing I do know is that from our circle theorems, if this is the radius here, the radius is going to touch this line at right angles. Okay, equally this one is touching the radius at right angles. So I know this. Okay, now if we just look at this little sketch I've done here, if I was to drop a ping pong ball into an ice cream cone, it wouldn't stick to one side. It would drop, wobble, and then rest in the ice cream cone. And the distance from here to here would be exactly the same as the distance from here to here. I hope that you can see that. Okay, if it isn't, you've defied all the laws of physics. Let me know and we'll make a fortune. So if this is the case, that that distance is the same as that distance, then imagine these 2 lines as an ice cream cone and this as a ping pong ball. the distance from here to where it touches the circle is exactly the same on both sides. So I can say that that distance and that distance are the same. So that helps us also. So if I just concern myself with this triangle here, okay, so the chord is the bottom of the triangle here, and I've got two sides. Now I know the two sides are the same. So if these two sides are the same, then these two angles must also be the same. Okay, if you go back to basic triangles, okay, we have an isosceles triangle because this side and this side are the same length, so this angle and this angle will be the same length. Now I know that the angles in a triangle add up to 180, so this plus this plus this equals 180. So 180 minus 40 gives me 140. Now 140 divided by 2, because those are our two angles, would give me 70 degrees. So I can say that that angle is 70 degrees and this angle is 70 degrees. Okay, so we're building up to what we need to know. But we've got this little tiny angle in here and this tiny angle in here, okay, because this is the radius touching the tangent. Now I know that the radius touches the tangent, as I said, at 90 degrees. So we have 70 degrees here. So this little angle in here must be 90 less the 70. Okay, I hope you can see that. So 20 plus 70 gives me my right angle. So equally this must be 20 degrees. Okay, because this is a radius and this is a radius, so they're equal length. So this angle and this angle must be the same. Now if this is a radius and this is a radius, then these two sides are equal, so these two angles are equal, because this small triangle here is also an isosceles triangle. So this angle here, okay, is going to be 180 less the 20 less the 20. So 180 less the 40 means that this angle here, okay, this angle is going to be 140 degrees. Okay, so now we know this is 140 degrees. This angle here at the circumference, we have this shape here, going back to the circle theorems, we have this shape here. The angle at the circumference is always half the angle at the centre. So if the angle at the centre is 140 degrees, then x equals 140 divided by 2, or you can write divided by 2. So x must equal 70 degrees. So that will be our answer. There is another way to do it using Circle's theorem, which is if I take this whole triangle here, okay, so this whole triangle here is resting on this tangent. This angle here Okay, if I just shade it in for you, this angle here and this angle here at x, the angle furthest away, must be equal, because if this is 70, this is 70, because of the alternate segment theorem. Okay, so we could have used the alternate segment theorem. Okay, which also gives us 70 degrees. So I know that this is true. So I wouldn't necessarily have had to gone through all the labour of finding these angles here, because once I know this is 70, this will also be 70. Okay? So I hope I've simplified it as much as I can. If you're screaming at the screen saying no you haven't, then I'm very sorry, but that's just really a question of practice. You need to practice all of the circle theorems so that you can get a better understanding of how these things are put together and how we can use them best. Okay, so it is always, as I say, practice. Okay, so I'll move on.